Good morning, everyone. Hope you had a good coffee this morning and a successful first day yesterday. For those who are new at Chillventer, my name is Breithaupt. I'm CEO of Heaten AS. We develop a high-temperature heat pump. Company was kind of 8 years in stealth mode, developed the technology, tested the technology, and we're currently scaling up into 1 to 6 megawatt scale on thermal heat. The story I want to tell you today is basically about how do you scale this technology within 12 to 15 months of development. Background is very simple. If you really want to tackle the current CO2 problem, it is all about industry's low temperature CO2 emissions. And for those of you who come from engineering or thermodynamics, we're still burning natural gas at 2000 degrees C, diluted down to some 200 degrees C, just wasting 90% of the exergy you have. That is actually a crime of the century, plus that we actually emit a lot of CO2 with this. And in actual, what we're here in Chillventer, we could actually reduce 90% of these emissions just by electrification of heat processes. The challenge is, can we bring heat pumps up into the 200 degrees C area? And this is what we've done. So just to give you a quick introduction on what is a very high temperature heat pump, because there's a lot of confusion in heat pump world about how do you categorize these heat pumps. And basically, what you see here is the supply temperature is actually what we bring into the process heat. And everything above 100 to 120 degrees C, process temperature, is supposed to be a very high temperature heat pump. That doesn't mean that the lower ranges are kind of obsolete. There are a lot of processes where you build up and have a staging process. Today and yesterday we had a lot of talks with people where we basically use low temperature heat pumps as the first step and then taking up the heat and develop it to higher process temperatures. Give you an idea, and you don't need to read the table. The table actually are available on the internet. It's from Professor Arpagaus. And the basically almost all industry areas can use this high temperature heat pumps. In particular, if you think about plastic industry extrusions, paper and pulp, brewery, food, almost all drying processes. Carbon capture recently, a very interesting application, because that helps actually bringing this technology into higher efficiency and making carbon capture a viable solution in the future. By the way, can you understand me properly here? So enjoying the music and the talk. Great, good. We've developed the machine already years ago, and this is a small machine, what you see here. These are 2 times 200 kilowatt thermal machines. Total running time after 3 years, almost 50,000 hours. So we are pretty sure that the technology platform is sound. The risk is, how can you make this rapidly into a big machine? Because industry, even carbon capture or customers we talk here, they basically need a 1 megawatt machine and more. So that's what I done with a new team since 1.5 years. And for those of you who come from mechanical engineering or you come from engine development, you know that you go to certain phases. You do an alpha machine, a beta machine, a gamma machine before you bring this into manufacturing. The risk in all these projects is that you get caught after the first alpha machine in an infinity loop of improving something which is already bad. Because bosses often ask you, I want the prototype as fast as possible. This kind of agile thinking. The problem is, you often deliver something which is not good enough to go into beta. So you're constantly caught in an infinity loop. So how can you change that? It's basically get your own team and culture and don't put it in the big company. Have front-end loading, and I will explain you what front-end loading in mechanical engineering means. And get a good bunch of good partners with you from an engineering point of view. Front-end loading is sometimes the opposite of rapid prototyping. There's just one sentence you need to get from here. It's basically make sure that you put the cost in this area, in the early projects, where the risks are low. You can lose money in the early days, but before you put money in very expensive assets, do a bit more work in the front. Spend your money up front before you really develop a big machine. So that's front-end loading, and it is not easy to defend towards management and investors, but if you don't do it, you run into problems when you go into alpha, beta, and gamma machine. So from our point of view, culture in the company is very important. So with my team, we do what we call intervention. Everyone can speak up in a management team meeting or an engineering team meeting if he or she thinks there's a risk. Now then, the other final thing is about success. If you do what I've just said, then basically you can celebrate your successes. And trust in the team, in an engineering team, is absolutely important to get the machine done. And then within 12 months, we went from here into this machine. So this is now the full-blown machine, which is just built. It's a V4, 1 megawatt thermal engine, fully designed, fully as a heat pump developed, and it is tested within the next 2-3 months. And I couldn't do this without the knowledge of the team we have actually brought together, without the team by itself and the culture and our partners. And basically, just to give the engineers a bit of an idea, June last year we started with the concept stage. We had a concept freeze after 7 months, went into detailed design freeze over here, and final drawings. That's the crankcase, by the way. And for those who would like to repeat it, now you can't because we put the IP out. So you don't see the intellectual property which is in this machine. Vice versa, another advice which we've seen a lot, we haven't developed a compressor, we have developed a heat pump. Because if you don't put the entire hydraulics and all the details, the heat exchangers, the pumps, the expansion valves, the control, you lose 3 to 7% of efficiency just by not properly designing the heat pump to the compressor. We had a lot of discussions in the last couple of days over here, and that remains an issue that people just, can we buy your compressor? No, you can't. Because we need to actually make sure that the rest of the machine is working properly. And if you go back just to look at how you compact you have to build if you want to bring it in a 20-foot container, then basically all the stresses you need to calculate to make sure that this is not breaking in the next 20,000 or 30,000 hours. You see how difficult it becomes even for good welders to bring this in and to make sure that even maintenance ports are there. So that, as you see, is currently built, but thanks to all the partners we're working with, and I would like to mention them here. AVL Schwick, one of the largest independent engine developers in the world, they built the Bugatti Veyron engine. Our machine is built next to the Bugatti Veyron engine. Chemours, very important for us from the refrigeration point of view, the refrigerants and all the combinations with our loops, because that is highly important. Loops is as important as refrigerants in high temperature heat pumps. KB is a small but very experienced chemical engineering mechanical company close to us, exemplarily good in computation, fluid dynamics and work. And Herbinger is, by the way, here at the Chillventer. They're probably one of the masters when it comes to passive valve developments. So that is absolutely a group of partners which we couldn't have done this rapid development if you don't bring in the expertise from this kind of people. Give you an artist impression, this system will be actually developed and built next year for a customer in Germany. This is the 4 megawatt system for a food industry, which is now connected to their factory over here. And yes, we will probably not have the real fancy housing. We developed it, but it's not always needed that you have the fancy housing. But it looks nice, and it is one of those housings which we probably use for demonstration. Thanks a lot.